I think I'll follow Tabea's steps and talk more about the affective underpinnings of trust. And specifically, I want to talk a bit about how touch can contribute to the way we trust or perceive someone or something as trustworthy, and specifically when we interact with a robot and not with another person. So first of all, we've seen a lot of definitions of trust, and I'm just going to briefly concentrate on the bits that are more relevant for my study that I'm going to present today. So as also Linda yesterday pointed out, the vulnerability aspect of trust is maybe sometimes the missing piece in trust research. So what does it mean to be vulnerable? So yes, it's about facing a risky or uncertain situation where we lack total control, but this is also an affective state, an emotional state of being vulnerable in front of someone else and being willing to share this vulnerability to someone else. And we do so because of the characteristics of the other party, of course, and embracing Meyer's definition, we can trust someone because of their abilities, skills to care, to take care of us, but also because of personal aspects such as having integrity and showing benevolence. And of course, people have different dispositional propensity to trust other people. But then also trust arises in a specific context, in a specific situation. It doesn't happen in a void, and probably trust also has different phases if we rely on someone else or something else in a different situation. Of course, we know trust is very important also for technology use. We don't want to use a technology that we don't trust, but we don't really know what type of trust applies to different technologies and different contexts. So a lot of trust research, to my understanding at least, concentrated on specific economic, organizational, or more practical contexts, such as the trust game, that is a very much used behavioral paradigm to assess trust. Do we want to share money with another person because of believing that the other person will reciprocate and give this money back to us? Can we trust an automated car? That's something very interesting, but to me, there's something missing. So again, looking about what vulnerability means, I think where a specific case of being very vulnerable is when we are in social exchanges where the self-other boundaries are reduced. And this is where affective social touch is very interesting, because touching one another is a very powerful way of reducing boundaries and being vulnerable, because it's risky. It's always risky to let someone else into your bodily boundaries. And it's also interesting because I was generating this picture using an AI, and when typing in touch-related keywords, I figured that AI is very bad at creating pictures of hands and touching hands, especially. So probably there are a lot of reasons that I don't know for this, but still I thought it was very, very interesting that AI struggle with hands and touching hands. That is a very complicated thing. So if we look more in general about technology-mediated interaction, social interactions, for example, virtual reality, we see that these experiences and hybrid interactions are very much visual and auditory, and touch is always, or most of the time, missing. And we need to find ways to bring touch back to face, like to potentially reduce something that I would call sensory loneliness. So being detached, disembodied when we interact virtually with another person. And there is a lot of stuff going on about that, trying to bring touch in these virtual exchanges. But there's also another step in technology, human technology interaction. So if we don't just interact with another person through a specific technology? Can we also interact with a technology that is just a machine, but is not designed to be a tool, but a social partner? For example, social or companion robots are literally designed to be social partners, not just tools. So I don't know if we want to interact with those robots, but this is at least what designers are trying to do, to make them social. And touch is a very big part of social exchanges. So can we trust a robot enough to want to be willing to touch and be touched by a robot? This is something that I'm going to try to tackle in this presentation. And I also wanted to mention this film that is very old, but very good at explaining what a perfect, ideal social robots would look like. So I'm not going to spoil it too much. If you didn't see it, just go watch it. But basically, there's a very strong relationship going on between this robot and the human. And this movie very well showed the ethical and moral implications of a robot being more and more similar to a human. But just to be humble and specific, just let's focus on the power of touch, or the bidirectional, probably, relationship between trust and touch. So when we look at the literature, there seems to be evidence telling us that social touch, when it comes from a robot, can be helpful to facilitate the perception of the robot as trustworthy. But this is only the case when this bodily contact is perceived as appropriate. That is not always true. And also, touch from a robot is not as pleasant as human touch, and sometimes fail to activate the same neurophysiological responses that are very powerful and an important part of social affective touch. When we are touched by another person, our heart rate decreases, our physiological system calms down, and this is probably not the case when this touch comes from a robot. But so some of the questions that we wanted to address with our research is then how a specific type of affective social touch, like comforting touch, can be perceived in human-robot interaction, and what aspects of the interaction can influence this, the way this touch is perceived, and maybe the perceived trustworthiness of the robot. And I also wanted to delve into the individual factors that modulate people's perceptions, because not just when it's not only about interacting with technology that we see differences at individual level. Also, affective touch is also very different from person to person. So the first step of our project has been an online study where we presented participants, adults, gender balance from all over the planet. We presented them several comics scenarios of human-human or human-robot interactions where comforting touch was happening. And we manipulated the partner role. So one of the two characters was the comforting one, providing comfort to the other partner, who was the vulnerable one. And by vulnerable here, I mean emotionally vulnerable. He or she or it was basically saying, I am sad. And then there was touch happening. So the one comforting the sad party was reaching to gently touch the sad party. And then we have the reciprocity phase where the touchee reciprocates touch and touch the toucher back. So in a closed loop of exchanging this comforting touch. And we've used self-reports to understand the perceived trustworthiness of the different characters using three different subscales. So the ability, integrity, and benevolence aspects that we've been discussing previously during the conference. We also checked whether the interaction was perceived as realistic and touch as appropriate and pleasant. We also checked the affective state that was attributed to the characters during these interactions, distinguishing between valence and arousal. And then at the end of the experiments, we also collected some measures on general individual differences that we thought could moderate the ratings of the different scenarios. So we asked about individuals' propensity to trust other people and also technology in general. And we also asked questions about people's general preferences for social affective touch in their everyday life. So the statistical approach, we've used generalized linear mixed effects model, and we, as fixed effects as predictors, we've used the experimental conditions that I've mentioned, the moderators, so the individual differences, also controlling for gender and taking into consideration the individual variability of the different participants, since we had a within subject repeated measure design. So this is how the model looks like for every dependent variable. And I'm also reporting R squared as a variance explained by the model as a measure of goodness of fit for the model, distinguishing between total and marginal variance explained. So the total variance explained by the whole model, and also the one explained by the fixed effects only. So when we remove the variability explained by individuals just being different. Looking at the results, so first of all, perceived trustworthiness decreased for human-robot interactions. We perceive the robot as less trustworthy than the human, especially when it's the robot to have the vulnerable role. So basically, being vulnerable emotionally is probably something that is for humans. We don't want a robot to be vulnerable. And when we look at the trustworthiness subscales, the biggest difference between human and robot is at the ability level. So basically, it seems that we perceive the human as being much more skilled to provide comfort to another person. But interestingly, we found some moderating effects at the level of individual differences. So as propensity to trust others was related to increased perceived trustworthiness of the human partner, in a similar way, propensity to trust technology in general increased the perceived trustworthiness of the robot, reducing the human-robot gap. When it comes to whether the interaction was perceived as realistic and touch as pleasant and appropriate, we have very similar results on these 3 dimensions. And again, the robot was perceived as being part of a less realistic, pleasant, and appropriate interaction, especially when it was the vulnerable one. And again, propensity to trust technology reduced this gap. So individual differences really play a big role. We also found a role, like an effect for the propensity to trust other people. So when people trusted other people more, they also rated the interaction as more realistic, touch as more appropriate and pleasant. So they were more positive about what they were observing. We've also asked participants to rate the perceived affective state associated with the characters in the different scenarios. And what we found was basically an effect on the arousal level. So first of all, human-robot interactions were perceived as more arousing, maybe because they were new, different, more surprising. We don't really know if this means that they were more or less positive. They were just more intense. And also there's the role of the phase of the tactile exchange, where reciprocity was associated with higher arousal. So it could be really important that we look at, since touch is a very dynamic, complex behavior, it could be really important to look at the different phases and how observers' perception change in different phases of a touch exchange. So to conclude, from this first study, we can see that a robot compared to a human partner is less trustworthy, especially when it shows emotional vulnerability. Comforting touch from a robot or with a robot is also perceived as less realistic, appropriate and pleasant, and more arousing than human-human touch. And as participants' propensity to trust other people is associated with more trustworthiness of human character. In the same way, propensity to trust technology is associated with a more positive perception of human-robot interactions. But what do we do next? So this was just an observational online study. It's not really immersive. It doesn't capture the way people would feel when being immersed in these interactions on a first-person perspective. And we want to do more. We want to create a way to understand how digital or technology-mediated touch can affect participants' feelings and perceptions. So with these very big collaborative projects, we are creating immersive virtual reality environments where people can be immersed from a first-person perspective in a social situation where they can be touched by another person, as in the video, but also a robot, for example. And we want to also bring haptic feedback in this situation. So my colleague, Robert Kirchner, you can see the publication in this slide, created this armband actuator that creates illusions of continuous movement through vibration, and we can see how being touched in a digital way can be perceived. And we also want to go beyond using just self-reports that, yes, are very important, but maybe limited in the way they can let us understand the reactions and the feelings that are associated with these hybrid experiences. So we want to use FNIRS, a neuroimaging technique, and also physiological measures such as heart rate to look at the effects of these types of touch with different partners. We want to look at the multisensory integration brain areas to see if this digital form of touch can activate the same multisensory integration in the brain. We want to see if the affective areas of the brain are also activated, not just by skin-to-skin real-life context, but also with digital forms of touch and when we interact with the robot. And lastly, we want to look at trust and find a way to use a neural index for trust. So from previous literature, there's this idea that trust is linked to decreased monitoring and cognitive control at the prefrontal cortex level. So we want to see if that's true, if that's different when we interact with a human or a robot. So that's it from my side. I want to thank you all for your attention and my co-authors for the online study. And I'm very much curious about your questions.
Yeah, thank you very much, Irene. Wow, really, really, really cool research, and that's going really deep, obviously, as also in terms of neural processes here. That would be my first question. How do you consider like the chances that this is actual locatable, so that we are actually able to locate trust processes in the brain, or what is the current state of the art there? What do we know about that?
Yeah, that's really tricky. I found just one main study using FNIRS to look at the neural location of trust, but of course we can debate about that. So, but I think this is always a problem with defining trust. There's trust as we define it, and we've defined it during the conference, and then there are mechanisms that are associated with trust, and we probably sometimes underestimate the correlation between trust and other measures, such as, for example, empathy or more pro-social mechanisms. So this cognitive account of the neural underpinnings of trust suggests that trust can be associated with this reduced monitoring and control. So our prefrontal cortex is what in many, many different ways help us monitoring whatever is going on inside and outside. And it seems that if we trust another person or another party, we can give up on this need for control and monitoring. That's, I think, the most interesting perspective that I found from previous literature.
Oh, very interesting. There is another question from the audience. Also, yeah, okay. First, take the question from the audience on YouTube, then John. So there's this consisting of 3 messages. Thank you for the talk. So it's asked by Mr. or Mrs. Bay. I cannot know which gender. Doesn't matter anyway. The question is regarding where robot touch is usually placed in the social context. So is it rather an acquaintance? Is it a close person? For the question asker, robot touch is more reliable when compared to touch from a stranger, so less risky, more trustworthy. So he or she just wonders about the potential individual differences or people's attitudes. So does the closeness play a role? So this is how I understand the question. Yeah, so I'm gonna chaotically try and respond to all these points. Yeah. So as for the individual differences in trust, preferences, and behaviors in general life, we've included a measure for that, self-referential measure for that, and we didn't find a big role of that. So, but it's also very general. So the social touch questionnaire that simply check how touch feeling you are is very general. So it captures preferences for social touch in all the contexts that you can, where you can find touch. So it's not very specific for specific situations. And I think that's really a problem, because the way we perceive and maybe want or do not want to use touch is very context specific. And the robot is a very new, weird, or different way of conceiving social touch. So whether this robot touch can be more reliable or predictable than human touch, maybe we are having a huge debate about whether predictability is associated with pleasantness when it comes to social touch. It may be that predictable tactile exchanges comes with less uncertainty and then maybe more pleasantness, but maybe not. When we trust someone, when we are very familiar with someone, uncertainty can be very rewarding, not risky. So it's maybe for a robot, yes, we want very reliable, predictable robot if we want to touch the robot, but maybe with people that's not the case, or not always. With very close friends, partners, or family members, there's a lot of variability going on, and that's pleasant and rewarding. Did I miss on another point of the questions? There was something else, maybe. The location, like touch location, I guess on the body. What parts of the body can be more appropriate for robot touch? I think that was not part of the question, but I'm interested. Yes. Okay. Yeah, so again, the body location of affective touch is a debated point. So first of all, affective touch is mediated by specific fibers in the skin that are activated by this specific gentle stroking. So these are slow conducting fibers that are mainly on the airy part of the skin. So the forearm, for example, face and head, and the back. Shoulders are very social, so a very social part of your body for social touch. But again, we don't know anything about the robot. We don't know anything about the social part of the body that can be social for a robot exchange. So that's interesting, and I don't know. Very, very interesting. So John, you wanted to ask a question.
Yeah, so this is great. So my question is sort of right on that note there. Touch is actually this multi-sensory thing, right? We have like discriminatory touch and we have affective touch. And they're actually different nervous systems and nervous fibers, right? One's myelinated, one's unmyelinated. I think it's the unmyelinated is the affective touch. It's sort of slow moving, right? And so what I'm wondering is there any research out there that has shown that our affective touch can be stimulated by a sophisticated automata, like whether machines can do that, or do I need to perceive what is touching me? Like animals can do it, right? So they don't need to be like, reasoning creatures, but they need to have something alive and emotional to them maybe, or something. So is there any research out there that shows that machines can stimulate this type of, these types of nerves?
So yes, from the sensory motor aspect. So we have two levels to perceive social touch as affective. The sensory aspect, so there are optimal body areas and speed for gentle stroking that is perceived as social affective touch because of the unmyelinated fibers that respond optimally to that type of touch. So most of affective touch research actually used a machine to apply constant and very predictable, like, a robot brushing you, for example. So that's the gold standard for affective touch research. If you want to isolate the sensory aspect of it, you can use a machine to create these optimal physical characteristics of touch. But then there's the top-down level, so the cognitive or metacognitive or more contextual aspects of it. And there is where we see the human-machine difference. So if you know that touch comes from a robot or a machine, it is not as pleasant as human-human touch. It's more like, so for example, this collaborator of us, Mary Jung, she looked at a comparison between seeing a mannequin, like a stick, or a robot, social robot, anthropomorphic, touching you, or a human. So the robot touch was more similar to the stick or non-social object compared to the human condition. So, but this is a top-down mechanism related to expectations and all those sort of top-down mechanisms.
Yeah, it's like an interesting thing there with uncertainty is that it's very difficult to stimulate affective touch in oneself. Like I can't make myself feel good by like just stroking my hand. It's really hard to do that. Like I need other people in part, I think, because uncertainty plays such an important role, like you were saying before. Yeah.
Yeah.
Thanks.
And also in social robotics, there's this debate, how predictable should the robot behave? Because if it's too predictable, there's not interest in it. There's nothing there to learn and to explore. So some level of uncertainty is needed.
Okay, so there was an addition by the former question. So to clarify the question again, sorry. What is the position of the robot in the social context? For example, stranger, acquaintance, or close one? I think that's depending on the robot and the context, right? So,
well, the robot can be either just the robot, so computer controlled or pre-programmed, but it can also be a digital twin, so it can be controlled by another human being. And of course, I would hypothesize that in that case, if there is a human being controlling a robot from a distance, the relationship between you and that person is what matters the most. So if you are interacting with a robot that is controlled by a familiar one, maybe the social norms that apply to that relationship will also apply to that human-robot interaction. Or if you are just interacting with a stranger, the expectations and social norms related to interacting with a stranger would apply. As for the robot as just being a machine, no humans involved, I think what social robots designers aim for is a robot that can become familiar, so that can interact with people on a more regular basis. But there's a problem with that because we don't know how to create history with robots. How do we make robots learn from previous experience and create new interactions that are based on the previous social experiences? So it's not a new robot every time that you interact with it. If it has to be like a social partner, how do we make this interaction familiar? This is, I guess, an open question.